Okay, so when you think about what causes climate change, what comes to mind? Probably cars, power plants, maybe airplanes, right? But what if I told you one of the biggest climate culprits is actually hiding right inside our homes and our offices? Let's dive into this because how we keep our buildings warm, well, it's a massive piece of the climate puzzle. And what does that look like in the real world? Get this. In a city like Vancouver, a whopping 57% of all carbon emissions come directly from buildings. And that's not from keeping the lights on or charging our phones. Nope. The vast majority of that comes from one single activity, burning natural gas just to keep our rooms warm and our water hot. So, yeah, that means the furnace humming away in the basement or the boiler system on the roof, the very technology we've relied on for decades to stay comfortable, is right at the heart of our urban climate problem. It's a system that, frankly, we can't afford anymore if we're serious about hitting our climate targets. Which brings us to a really simple but kinda huge conclusion. To really decarbonize our cities, we absolutely have to change the way we heat our homes. And that search for a better way has led engineers to a technology that's actually been around for a while, but is now, finally, ready for its moment in the spotlight. So, say hello to the heat pump. This is the number one contender to replace the millions of gas furnaces chugging away in our buildings. But what actually makes it so different? Well, the fundamental difference is right here, and it's a total game changer. A gas furnace is basically a tiny, controlled campfire in a box. It creates heat by burning fuel. A heat pump, on the other hand, is more like a heat mover. It doesn't make new heat, it just finds existing heat from the outside air and moves it inside. Honestly, the best way to wrap your head around this is to think of a refrigerator, but working in reverse. Your fridge doesn't create cold, right? It just moves heat from inside the box to the outside, which makes the inside feel cool. A heat pump does the exact opposite. It finds heat in the cold outside air and pumps it right into your home. The magic trick behind all this is something called the vapor compression cycle. It sounds super technical, but as you can see, it's really just a four-step loop. A special liquid, called a refrigerant, absorbs heat from the outside air. Then it gets squeezed by a compressor, which makes it super hot. That heat then gets released inside your home, and the whole cycle just starts over. It's this continuous process of grabbing, squeezing, and releasing heat. And here's where things get kind of wild. Because it's moving heat instead of creating it from scratch, a heat pump can be incredibly efficient. We're talking over 300% efficient. That means for every 1 unit of electricity it uses, it can deliver 3 or more units of heat. And no, that's not some kind of magic that breaks the laws of physics. It's just really, really clever engineering. So, case closed, right? Heat pumps are the perfect answer. Let's just swap everything out and call it a day. Well, not so fast. This is where our story takes a really interesting and pretty critical turn. As we push for technology that's even better for the environment, we introduce a new kind of risk that we have to manage. You see, the special liquids that make this whole process work, the refrigerants, they have their own environmental impact. We're phasing out the old ones because they're powerful greenhouse gases. But the new, much more climate-friendly replacements, they come with a catch. And this chart right here lays it out perfectly. The old stuff, R410A, is classified as A1. And notice that flammability rating. No. Simple enough. But the new, greener replacement, R32, is classified as A2L. Now look at its rating. It says low flammability. And low, well, low is definitely not no. So that's the big question, isn't it? As we start putting millions of these new, more efficient systems into our homes, our schools, our offices, how do we make absolutely sure that a solution for one problem doesn't end up creating a totally different one? How do we innovate safely? Thankfully, there's an answer. It's basically a safety playbook for engineers. In Canada, it's a standard called CSA B52, but there are similar codes and rulebooks all over the world. They provide super detailed instructions on how to safely install and operate any equipment that contains these new refrigerants. And check out this quote from an industry professional because it cuts right to the heart of it. We designed to CSA B52 to ensure that systems operate safely, and should there be a refrigerant leak, people, hopefully, don't die, and we do not cause a fire. This isn't just about paperwork. The whole point of this dense, technical document is to prevent a catastrophe. So how do engineers actually use this playbook? Well, it's like following this exact checklist. First, they have to identify the building's use. Is it a single-family home, a hospital, a school? Then, they classify the type of system and the specific refrigerant being used. And based on all those inputs, the code tells them exactly what safety measures are needed, like maybe requiring special ventilation or putting limits on how much refrigerant can be in one space. And look, the reason these rules are so incredibly strict isn't just theoretical. The tragic event at the Fernie Memorial Arena back in 2017, where a leak of ammonia, a different kind of refrigerant, led to 3 deaths. That's a heartbreaking reminder of what's at stake. These safety codes are written in the shadow of events like that to make sure they never happen again. So all of this, it really paints a bigger picture, you know? The path to a cleaner, decarbonized future isn't just about inventing some brilliant new technology. It's about how we thoughtfully and carefully and safely integrate it into the world we already live in. And that is the key thing to understand here. This entire transition to clean heating is a deliberate balancing act. On one side of the scale, we're pushing for sustainability with new, climate-friendly refrigerants. And on the other, we're using these detailed safety codes to manage the new risks they bring. It's a constant dance between progress and caution. And that leaves us with one final, big question to chew on. The story of the heat pump is really the story of our entire green transition in miniature. As we keep developing amazing new tech to solve our biggest problems, are we also preparing ourselves to understand, respect, and manage the new and sometimes unexpected challenges they're going to bring with them?